We've set things up so far so that this expression will work. Here I've got a function that wants a record that has a field x, and it's getting x, and applying that to a record that does in fact have an x field, which is of type number as expected. And so we saw how this expression in blue here that has type x colon num, arrow num, and we saw that this record type has a record type x colon num, and our rule for function calls says that we need that type here, this tau2 is this one, to match up with the expected argument type, that's this one. Everything matches, so we use this last one as the type of the expression, type of the overall function call expression. But not everything we might like to write is accommodated by our type system so far. Here's another example where I have a function that wants a record that has x as a number and y as a number, and it's going to get the x out. And I'm passing it a record. This record that I'm passing it has a y and an x, and so following our type rule we would derive y colon num and x colon num. And the problem is that this type doesn't exactly match the argument to the function. The x and the y are swapped. So our type rules right now, our type checker would not actually allow this. But we know it's going to work fine because nothing about our operations on get and set depend on the order of the fields. So we would like to adjust our type system to make this work. We don't want to require that tau2 here match exactly the tau2 of the actual argument expression. And before looking at that, let me show you another example that doesn't work. Here I've got a function that wants an argument that's a record that has a field x, and it's going to look up x. What we're supplying it is a record that has x and y. So it's not just ordering here, but the argument supplies extra fields. Extra fields should be okay as far as the function is concerned. It's only going to get the x field. It doesn't matter if there's an extra y field. So we would like to allow that, but again, because we require an exact match right now between our argument and the function arguments type, then this is not allowed. The solution to this is to introduce the notion of subtype. So we write tau less than or equal to tau prime, or pronounce it, tau is a subtype of tau prime, whenever any expression that has a type tau is going to work out if we use it in a place that wants a tau prime. So, for example, if we have a record that has both x and y fields, and some context is expecting a record with just x, then it's going to be fine to have the extra field there. It's not going to create any trouble. And the way we formalize that is to say that this type, x num, y num, is a subtype of just x num. Similarly, we can say that y and x, that's a subtype of x and y. If you need an x and y, it's fine to have a y and x as long as those two types are the same. And we will also want to say, just so we don't have to say subtype or equal, we'll just make subtype include equal, and that's why we use less than or equal instead of less than. So a record with an x num field is a subtype of itself. On the other hand, if some context wants a record with an x and y field, and what we've got is a record with just an x field, we cannot pass that in, right? This smaller record type is not a subtype of the record type that has x and y because the context might actually try to use the y. So the intuition on this less than is not a size, as you can see, because this one looks smaller on paper. The intuition is that a type is a subtype when it corresponds to a smaller set of values. That is, there's a certain set of values that includes records that at least have an x field with a num, of type num. And only part of that set of values, only a subset of it, has an x field and also a y field that's of type number. Right, so that's why we use less than here. It corresponds to an intuition of sets of values that fit a type. And it's a subtype when there are fewer values, when it's more specialized in some way, such as being more specialized by also having a y field. To put this subtype rule into our formal notation, we would write it like this. We say that this record type on the left is a subtype of the record type on the right when the one on the left has at least all of the fields that are in the right. That is, if we take the set of field names on the right and check the set of field names on the left, that everything on the left, the ones on the left cover all the ones on the right. Also, there's an extra constraint that whenever we have something on both the left and the right, then the types have to match up for that same field name. There's some more rules we need, again, because we want subtypes to include type equality. So num is a subtype of num, bool is a subtype of bool, and a function type is a subtype of itself as well. Of course, number is not going to be a subtype of a record because a number doesn't have any fields, and a record can't be a subtype of number because you can't actually add a number, and so on. We take advantage of this new subtype operation in our rule for a function application. So now we have E1 applied to E2. We get a type for E1. We get a type for E2, which is some tau2. Tau2 doesn't have to match exactly tau1. It just has to be a subtype. That is, it has to correspond to a value that's suitable for use in the same way that all tau1 values are. And as long as those things are, that subtype relation holds, function call result is the result of the function. So for example, if we have this function that's expecting a record that has an x field of type num, and we provide a record that has an x and y field where they're both num, that's okay because x num, y num is a subtype of x num. If we have a function that wants y and x in a record, both of type num, and we have x and y, both of type num, then again we'll allow that because our subtype ordering allows us to reorder the fields inside of a record as long as we keep the types the same. And finally, if we look at this expression, here is a function that wants a record that has an x and a y. We're only giving it a function that takes a y, though. And you can see that this will go wrong. So we want to rule that out. And this is ruled out because y of type num is not a subtype of x num, y num. Right? Even if we change this x to a y right here, our type system should rule this out because we don't look in the body to see what kinds of things are being used. From the outside, we just say this function demands a record of type x num, y num as a record.